Hi guys, welcome back to another video. This is a continuation of the integration by parts videos. Here we're going to be looking at the integral of e power x into sin x dx. This is somewhat of a favorite question of IB, and they like to ask this question. They've asked this question several times in the past papers. It is a tricky sum, and there's a certain method or a certain way of thinking which is required to solve this sum. The basics of integration by parts has been covered in this video, which will be in the cards about now and in the description. And using integration by parts to solve the integral of inverse of tan x or any inverse trigonometric function is in this video, and that would be in the cards right now and in the description. So I strongly urge you guys to check out those videos before coming to this, as those will give you a solid foundation. So let's look at this sum. So I'm going to assume that you guys are already familiar with how integration by parts works. So e power x is an exponential function and sin x is a trigonometric function. According to the rules of Eilate, u would be equal to sin x and dv would be equal to e power x. Now I want to calculate du, so I'll differentiate it and I'll get cos x. Now in this case, if I integrate dv, I would still get e power x. So simplifying this, get du is equal to cos x dx. Now I'm going to be using this equation over here and writing it in the form of uv minus v du. U would be sin x and v is e power x minus integral of v e power x and du is cos x dx. As you can see here, we cannot simplify this any further, and we cannot leave the answer just like this because there's another integral. So yeah, we have to use by parts on that again. But before doing that, I would recommend that you write but before doing that, I'm just going to write this solution and equate it to the original question that we started out, so that it just gives you a better view of what I'm going to do next. So yeah, let me just write it in a proper equation form. So this is basically what we've come up with so far, and now I'm going to solve the integral of e power x into cosine x dx separately. So very similar to the previous sum, where this is an exponential function and this is a trigonometric function, and therefore u would be cosine x and dv would be e power x. So du over dx would be, in this case, negative sin x, because the derivative of cos x is negative sin x. If we're writing it in terms of du, it would be negative sin x dx. And here we have to calculate v by integrating both sides, and that would still be equal to e power x. The integral or the derivative of e power x is always e power x. So now that we have the four terms, we're going to write it in the same form using this function again. So u would be cos x, v would be e power x minus integral of e power x into negative sin x dx. So if I simplify that, that would be e power cos x plus e power x sin x dx. So as you can see, we arrive back at e power x sin x, which was the original question. If now you want to integrate e power x sin x using by parts again, well, it's going to keep forming a loop and you're never going to get an answer which is free of any integral. So now how do we get an answer free of any integral? Our aim here is to remove the integral inside this equation so that we get a simple answer to e power x which does not involve any integrals. So to do that, we need to substitute the integral of e power x cos x dx. Just now we calculated that the integral of e power x cos x dx is basically this equation over here. We can substitute that into this equation. So that would be nothing but over here now you would somewhat understand why I wrote the e power x sin x dx. So yeah, so that now it's much simpler to simplify. So the integral of e power x cos x dx, which we calculated, was e power x cos x plus integral of, oh, let's not forget to add the whole brackets here, sin x dx. So now we have to factor in the negative sign, so that would be, let me just simplify this real fast, e power x sin x dx. So our aim is to get a solution which does not involve any integrals. So over here we can see that the only integrals left are e power x sin x. Now what we can do is bring all the integral of e power x into sin x dx to one side and write the equation with the integral of e power x sin x as the subject. So that would be e power x sin x dx plus integral of e power x sin x dx is equal to e power x sin x minus e power x cos x. Integrals can also be added like algebraic functions, so we can just add this and therefore we get 2 into e power x sin x dx, which is equal to, we were initially asked to calculate the integral of e power x sin x dx, so we cannot just leave this 2 hanging around here. So basically we're gonna remove the 2 and bring it to the other side, and we would get, so yeah, half e power x sin x minus half e power x cos x. So that is your final solution. Here what you should observe and remember is, when you have this integration by parts sum which yields more integrals which have to be solved by parts again, yielding more and more integrals, such that there's like an endless number of integrals, or if it's yielding the same integral and you're unable to achieve an answer which does not contain an integral, you should look at ways to substitute whatever integrals you have into the main equation so that you can remove it from the main solution and will achieve an answer similar to this. I hope you can understand the thinking that goes on while solving this problem, as that is more important than actually knowing how to solve this very specific problem, because yeah, the IB might throw different variations of this and you should be prepared to solve all of them. So hopefully this video was very helpful. Be sure to check out the other integration by parts videos which I've linked below, and be sure to check out all the other IB Math HL videos I've made, including various shortcuts which would be super helpful in saving time. So thank you for watching, and I hope to catch you in the next video. And guys, don't forget to add the +C.